All right, good morning and welcome back to Intro to Statistics. So today we're going to talk about probability distributions. This is section 6.1. It's really the intro to it. So I noticed some of the questions are a little long, so I wanted to kind of give you an idea of what we're doing first. So the first thing is to figure out if it's a probability distribution. Things we have to check out are the probabilities of all the events there are equal to 1, and all the probabilities are somewhere between 0, okay, and 1. All of them have to be between 0 and 1. Furthermore, they have to add up to exactly 1. Okay, that's how you tell a probability distribution. Okay, if that's true, then it is, check. I did not say anything about the x's. Okay, so we're not worrying about the x's. This is just the probabilities that are attached to the x's. That's all we care about. Okay, so if I wanted to double check this one, go to our calculator here a little bit. Okay, and all I would do is type in 0.23 plus 0.15 plus 0.1525 plus 0.27 plus 0.1 equals, hey, it's 1. This is a probability distribution. But some of the x's are negative. Don't care. We just care about the probability parts. Okay, so we're not looking at the x's part. That's the value of the event. The probability that it happens, that's what we care about. Okay, they don't have to be, if they're not, they skip some. Don't care. We don't say anything about the x's. We only care about the probabilities. Okay, that's all we care about. Okay, now things are going to ask you, is it a probability distribution? Check. Yes, it is. Okay, they're going to ask us for the average. Okay, what the mean is or what the average is. Okay, and the notation I use, the more advanced statistics classes we use, is this expected value of x. So when you see this word expected, that's a vocabulary word. That means do this. Okay, so that's not an English word anymore. That's a statistics word. We're going to say expected means we have to do this. And what we're going to do, the formula for this is the sum of, okay, so we're going to add these up, value of the event times the probability of the event. So we want to add up the value of the event times the probability of those events. We're going to sum all of that up. And that is going to be our average or mean value for this distribution. Okay, so that's how we're going to do that. Okay, the reason I use this method is because they're also going to ask us for the standard deviation. So what we want to do is say, what's the expected value of x squared? And that is the sum of the value of the x's squared times the probability of x's. Okay, so each of our values, each of our x values, we're going to square. So if you type in -3 squared and it gives you -9, no, I messed up. Okay, so be careful when you say -3 squared. Make sure you've typed it in this way. Because if you type in -3 squared, the calculator will tell you -9. You know that's a lie because -3 times -3, right? Make sure the calculator knows what you're doing. You know it's a positive number. Okay, so the calculator tells you it's -9. Realize that the calculator did what it was supposed to do. It just didn't ask it to do the right thing. Okay, so just be careful you're getting positive numbers out of this. Okay, so expected value of x squared, okay, is just the sum of x squared times p of x. So I've got more. You're not going to need this one in this particular class, but if I do x cubed, that's the sum of the cube of x. So we're just going to multiply like 3 times 3 times 3 would be 27 times probability of x. And we're going to add all of those up. The ascents of pattern. So the last one we'll type in is this one. P of x fourth. This is the last one that we're statistics we just use up to x fourth. Okay, that's the sum of x to the fourth times p of x. Okay. Why we use these? P of x. These are all called moments. Okay. So like a moment. They mean moment of inertia. They don't mean like we take a moment to tell you this. They mean like a moment of inertia is how they're using this word. Okay, and this is equal to the sum of x times p of x. Okay, value of the event times the probability of the event, add them all up. Show you a slightly nicer way. The reason why I want to do it this way is because they're going to ask us for the standard deviation. And the formula they give you for standard deviation is terrible. Okay, the formula that I use is the same formula, is e of x squared minus e of x squared. The reason I do that is because it's a little bit easier to calculate these things than it is to do what they want us to do. And this is actually the variance. Okay, it's x squared. Remember, it's the variance. So we have to take the square root. Okay, so the square root of x squared, that's going to be our standard deviation. That's how we're going to get that. Okay, in the face-to-face classes I teach, I usually don't actually ask this question to do all of this because there's a lot of places to mess up. Okay, and I don't want to make it that arithmetic based, but there's a lot of places to make a small error and then get the thing wrong. Okay, so be careful when you're doing this. I'm going to show you a way that I do it so it's a little bit easier to follow along. If you were wondering, well, why are we doing this? Well, this one, I don't know the exact formula, but that's related to something called skew, which tells you if it's right-sided or left-sided tail. Okay, and then for the x to the fourth, that is related to something called kurtosis, which tells you how fast a distribution drops off. Okay, so if you have a distribution that's kind of very shallow, or you could have a distribution that kind of drops off very quickly. Okay, this would have high kurtosis, this is low kurtosis. Nobody's ever going to ask you this. Okay, so don't worry about, like, I have to memorize this. It's just that if you ever take a more advanced stats class, you're going to need something like this. The only time I've ever had somebody come back and say, a student took like an advanced economics class, said, hey, we talked about kurtosis today, and I knew what it was. I was the only one. That's great. So chances are you're never going to see this, and you can safely disregard most of this. But that's what we use this for. The reason I teach it like this is simply because I want you to be able to have a pattern, because all this is pattern, rather than trying to memorize a bunch of different formulas. Okay, and I'm not interested in trying to make you memorize these. Okay, I usually make you guys memorize mean, value of the event times the probability of the event, and then I don't really worry too much about the other ones. I almost never ask this one. Now Alex does, so if I pick problems out of Alex to put on your quiz, you're going to be doing this. Okay, and I probably will. My apologies, but I don't have a lot of control over. I can pick some questions, but when they deal you that question, I don't have a lot of control after that point. So you might be on the hook to do this, so we'll practice it, but if it's my choice, I will try to choose something that isn't going to do this to you. So when I'm looking at this problem here, it says find the mean. Okay, what's this? What we're going to do? Okay, so I'm going to try here. Okay, so what we're going to do is we're going to make a column. We have x. We have our probabilities of x's. So all I'm going to do is pretty much write down the same table we have. So negative 3.23. Negative 2.15, 7. They skipped. Like, that's okay. They skipped. 0.25, 9 is 0.27, and then 10 is 0.1. So 0.10. I could put the leading zeros in here. That's good for best practices. If we have people who are going into nursing or medical, you guys are going to want to put the leading zeros because that's best practice. Okay, and now we want to figure out the mean. All we're going to do is take what is our x value times the probability value. That's all we're going to do here. Say value of x times the probability of x. Okay, so what we're going to do is we're just going to multiply these across. Okay, go ahead and this off to the side. I don't want to type in all the negative numbers, so I know this is going to be negative 3, so I'm just going to say 3 times. So I have 3 there? I don't. So I have 3 times 0.23. 0.23. We're just going to say that's negative 0.69. Okay, just carrying the negative through. Okay, this was 2 times let's go back to here. 2 times 0.15. We got 0.3. So this was I'm going to do my best to line these up. Okay. 7 times 0.25. So if I have 7 quarters, it should be like less than $2. But since we have the calculator, 7 times 0.25. So $1.75, so we have 1.75, okay? 9 times, so make your kindergarten, your first grade teacher proud by typing all this in and lining up all of our decimal places, okay? Into 2.3, and then we have 10 times point, this is 10 dimes is going to be $1. Okay, I could do that one. Okay, and all we're going to do is we're going to add all of these up. Okay, so now I'll put the negatives in because we've got some minuses. So I'm going to put negative 0.69, okay, plus, is this negative? This was negative, so don't forget that. Plus negative 0.3, okay, that's what's going on here. Plus 1.65, 1.75, plus 2.43 plus 1. Okay, and that is our expected value, 4.19. Yes, I will ask you one like this. Okay, so we're going to get 4.19. So all we did was take value of the event times the probability of the event, and then we added these up. This is the sum of x times p of x. Okay, we did the x times p of x is in our column right here. We just added them up. That's all we did. Okay, so that's going to be 4.19 here. Okay, they went for 3 decimal places. I don't like this because it makes me nervous. 4.19. Is it like maybe I'm supposed to do 4.190 or not? Okay, I'm not sure. And then I'm not happy with the way this problem is written because if I say check, they're going to say, oh, no, make sure you've done them all. So I can't know I got the right answer until like the very end. Okay, now we're going to look at the standard deviation. Let me pause this for 1 second. All right, so when I want to do standard deviation, okay, formula for that, the formula for standard deviation here, it's going to be e x squared minus e of x squared. Okay, that's going to be our sigma squared here. It's our variance. Okay, you have to take the square root when we're done. So I've already calculated e of x. All we have to do is square this number, and that's this part. Now I've got to get this part. Okay, this e of x squared. Now remember that's x squared times the probability of x. And now we're going to add this up. Okay, so what I would recommend is we're going to make 2 new columns here. We're just going to keep going with this. It's going to be a long problem, right? So we're just going to square our x. So it's going to be our x squared column. So negative 3 times negative 3 is 9. Negative 2 times negative 2 is 4. 7 by 7 is 49. 9 by 9 is 81. 10 by 10 is 100. Okay. And then I've done this problem a number, not this particular one, but I've done problems like this a number of times. I would recommend that your next column be the p of x because you are used to multiplying 2 columns next to each other. Having to look at this and go back here, you are going to multiply this accidentally. You don't want to do that. Okay, so we're just going to type in our p of x here. I'm just going to translate. I'm just going to copy over. This is 0.23, 0.15, 0.25, 0.27, and then 0.10. Okay, and all this is, I just translated these numbers over. So all we're going to do at this point for this next part is we're just going to multiply together the x squared times the p of x. Okay, we're just going to multiply column, I guess, 4 and 5 together. Okay, and we're just going to write those numbers down. Okay, so here we have, turn on. So we're just going to write this down. We have this up to the side, 9 times, really? Yeah. 9 times 0.23, okay, 0.15, or sorry, 4 times 0.15, okay, 49 times 0.25, 81 times 0.27, and then 100 times 0.10. Okay, and we're just going to write those numbers down. Okay, so we're just going to. Can I go back up? I can't go back up. I thought I was going to be clever. I'm not. Okay, Okay, so we're just going to write this number down. So we have 10. Okay, 81 times 0.27, that was 21.87. Okay, that sounds delightful. That's 21.87 here. 21.87. Okay, we have 49 times 0.25, 12.25, it looks like, 12.25. So this one was 12.25. Okay, 4 times 0.15, that's 6. So we have 4 times 0.15. Okay, we got 0.6. So this was 0.60. And then 9 times 0.23. That's the first one he did. 9 times 0.23 times 0.23 equals, and we end up with 2.07. 2.07. So all we're going to do is add all these guys up. Okay, that's all we're going to do here. All right, so I want 2.07 plus 0.60, 0.60 plus 12.25 plus 21.87, okay, plus 10. It's 46.79. 6.79. Okay, so our variance here, okay, our variance, sigma squared, is equal to E of x squared, that's this number right here, minus E of x squared. So we're going to take, this is 46.79 minus 4.19 squared. That's equal to our variance. Okay, so let's go back to our calculator. So we're going to take our 46.79 minus, what was the previous answer we got? That was 41, or 4.19, 4.19. We're going to use this little squared button right here. Okay. At 29.2339. 29.2339. Okay, that's our variance. If they ask you the variance, got it. Okay, they didn't. They asked for standard deviation. So what we have to do is take the square root of this. So we're going to take the second function, square root, second function, answer, and that is going to be our square root for this. Okay, and I ended up with the 3 decimal, how many decimal places do they want? Okay, so we'll get around to answering that. 3 decimal places if necessary, so let's go ahead and have a look. So that is, we have a calculator, that is 5.4068. Let's do it 5.407. Okay, so we're going to say this is 5.407. That's what we're going to type in. So this was, this up. Okay, so this was 5.407. And again, I apologize for the fact that these problems take a long time. I generally don't ask them. If I find one that's small, I might pick that one. So if we have 3 entries, like that might be acceptable. More than that, it starts to take a little long to do this. And there's got a lot of places to make mistakes. So I don't like that. That's how you do one of these. I will do another one. Okay, a video perhaps to show us how to do this. So this was 6.1, number 3, and put that one in the bag. But that's how I tend to do this. There are other ways. Okay, you can follow the calculator, but there are even more calculations. So I'll let you go with that, and I'll see you in the next video. Thank you.